In this presentation, we will be discussing friction at angles. In this experiment, we will be testing several different masses in order to get a variety of data. In order to more accurately find the masses of your masses, we'll be taking one of these little steel balls on the scale, and then from there, we will be subtracting that from the total mass that you measured later on.
So you did it at 10%?
Be sure to complete this process for each mass that you plan to be testing. Now it's time to begin the first part of our experiment. Being that the cup is designed to slide down the table until it falls, it's important to have something soft at the bottom to soften the impact, so you don't dent in your cup. You'll also want to tape down the weight inside the cup, so when you are tipping it over, the weight doesn't hit the side of the cup and therefore create an applied force that will skew your data. To measure the angles, we'll be using an app that I'm sure you use regularly in your day-to-day life. The Compass app has a separate mode where, using your phone's gyroscope, it can be used to measure angles by tilting it. Tape it down to the table so it doesn't slide along with your cup. Tilt the table slowly. You're going to want as accurate as a measurement of the angle as you can get. Once the cup starts moving, record that angle. You're going to want to do this a few times, and then find the average of the angles that you recorded. What we got from our first batch was around 16 degrees. In order to find the coefficient of friction, you will need the tangent of this angle. Now, if you did run the experiment through for all your masses, you will find the coefficient of friction is the exact same for all of them. What's important to take away from this is that mass will not change the angle nor the coefficient of friction needed for your cup to slide down the ramp. No matter how heavy or how light the mass in your cup is, the coefficient of friction will always remain the same. The final part of our experiment will be us actually finding force friction. Force friction is mu Fn, or coefficient of friction times force normal. Before we start the actual second part of this experiment, however, you're going to need to run some numbers. You will be finding the theoretical force friction, or what the friction should look like once you get to the experiment. Now, force normal, of course, is just the counterpart to force gravity. So that's 9.81 times your various masses, multiplied by coefficient of friction, which you've solved for by now. Now you get to use the spring instrument to find your actual force of friction. Tie a string around this and the other end of the string around your cup. Gently pull on it until your cup barely begins to move. The little ticks on the side of the instrument is your friction in newtons. However, it's important that you don't do this at too high of an angle because, well, then your cup's just going to fall over. Here I have my theoretical on the left and my experimental forces of friction on the right. As you can see, they don't exactly match up. If yours don't match up, then it's an issue with your coefficient of friction. You're going to need to go back, find a new coefficient of friction, plug in the numbers again, and see how well that does. And with that, congratulations. Now you can measure force friction.